This is part 2 of section 3.3. We're now being asked to write each of these expressions in condensed form. Now, before we start this, I want to point out to you right here that we have a number in front of a logarithm. And if you look at our properties, we're starting on this side, and neither of these allow for a constant in front of our logarithm. That means we're going to have to use this property first. We have to get any coefficient as an exponent before we can apply either of these properties. So, first step here is I need to make this 2 go up there. So this is now log base 2. I'll go ahead and write it as 5 squared, although almost certainly you will end up writing it as 25, plus log 2, 9, minus log base 2 of 75. Now I can combine, let's combine these two, and that's 25 right there. So what I have here is log base 2 of 25 times 9. Minus log base 2 of 75. Okay, and I'm not even, well, let's go ahead and do that. 25 times 9 is 225. And now we can combine these using division. Okay, and if you do that division, you end up with log base 2 of 3. Okay, now let's do this one. Our multiplier is in front, but these are in brackets, so I can go ahead and combine these. And then I'll deal with that 1/2 after I've done that. Now, since this is an addition, I can combine these using multiplication. And I would get 1/2 log of x plus 1, x minus 1. Okay, now that's a difference of squares, so go ahead and multiply that together. Make sure you keep it in parentheses. Okay, now deal with the multiplier. It becomes an exponent. And then they will want you to turn this into a root. So this is log of the square root of x squared minus 1. And that's as simplified as you can get that. Okay. So this is an interesting application of logarithms. We can estimate really large numbers using this. And what this says is a positive number k has n plus 1 digits if and only if log of k, that's common log of k, is in the interval n plus 1. Now, I know this probably doesn't make a whole lot of sense yet. It should here. Okay? We want to write an estimate of the number k equal to 234 raised to the 567th power in scientific notation. Now, this is, of course, a huge number. So the first thing I want to do is I want to take log of k. Okay, so this is log of 234 to the 567th power. Okay, now I can move this into the front. And then you can use your calculator. to get an estimate of this. And this is approximately 1343.345. And it keeps going. Okay? So what have I just done? What do I know? K has n plus 1 digits if this value is between n and n plus 1. Well, this number is between 1343 and 1344. Okay, so since this number is between these two, n would be 1343, n plus 1 is 1344. It has n plus 1 digits, which is right here, so this will have 1344 digits. Really big number. Okay, so what I can do is if I start off right here, if I convert this to exponential form, I have k is equal to 10 to the I should probably write out more digits here because they will want it. This is also 391. Okay, now if you use your properties of exponents, I can rewrite this as 10 to the 0.345391 times 10 to the 1343. If you add these back together, you get this, and we're allowed to do that with exponents. Now get a decimal approximation for this. And keep this. And you have your approximation, you have in scientific notation.